Assalamualaikum and a very good day. My name is Masrizal bin Mansur and I'm in group CEH2431 and this is my student ID 2021 120 and 007, and the topic that we're going to discuss for today, it will be Aeolian environment. For my part here, I'm going to discuss about the introduction to Aeolian environment. So basically, what is the Aeolian environment? So Aeolian environment is also spelled as Aeolian is the pattern to wind activity in the study of geology and weather, and specifically to the wind's ability to shape the surface of the Earth or other planets. So basically, the Aeolian environment is the act of the wind activity, and it will cause the changes of the surface of the Earth or the other planets, because Aeolian environment also exists in the Mars and the Pluto. So winds also may erode, transport, and deposit materials, and are effective agents in regions with sparse vegetation, a lack of soil moisture, and a large supply of unconsolidated sediments. So, this will be discussed about the arid environment. They are typically associated with arid environment, which is the area that receives 250 millimeter per year, less than 250 millimeter per year precipitation, and for two main reasons. The first one is the water is much more powerful transit agent than the air due to its fluid properties. So, a lack of water is prerequisite for air to be the dominant sedimentary force. The second one, lack of water leads to scarce vegetation, so it further facilitates wind-driven erosion because vegetation can stabilize sediment and prevent it being easily moved around. So we're going to talk about the wind erosion. Wind erosion is the detachment, transportation, and depositional of loose topsoil or sand by the method of this process, which is the deflation, abrasion, and attrition. So basically, deflation is the removal of loose material from the Earth's surface. Abrasion is needed to wearing away of rocks and removal of soil by particles or load carried by the wind. So the attrition is very important because it is responsible for turning boulders into smaller rocks and eventually into sand. Because attrition, it is because in the attrition, wind causes the rock and boulders to bump each other until they become sediments like sands. So this will be the the figure of the process of deflation and abrasion. Next, we're going to discuss about the most common Aeolian environment, which is the Aeolian trends. The first one is deserts. Desert is the continental area that receives little precipitation. There are arid areas that receive less than 250 millimeter per year precipitation, as we discussed before. So, for areas that receive average precipitation of between 250 and 500 millimeter per year, it is defined as semi-arid because they are not usually considered to be true deserts. The second one is Urk and Urk. It is Arabic for sand, is an area where sand has accumulated as a result of Aeolian processes. So Urk are prominent features of some desert in which is in desert of Arabia, the Sahara, and Namibia. But in fact, most deserts are not sandy, but are large areas known as rocky deserts. So will be the examples of the Aeolian terrains, the most common one, which is in Sahara, relic Elks in the western Nebraska, the Gilbert Desert in Australia, and also the Pinnacles in Australia. So we're going to talk about the Aeolian trends, the less common one, which is in the glacial outwash. So glacial outwash areas are places where used detritus that has been released from melting ice remains exposed on the surface for long periods of time, and because plant growth and soil formation is slow, because they appear to be in the periglacial regions. So the availability of easily eroded sediment coupled with sparse vegetation and strong persistent winds in the region of an active glacier, it is enhanced Aeolian activity. Usually, wind blowing from over the outwash plain can pick up at sand and redeposit it locally. So usually it is against the topographic features such as the site of the valley. And these patches also of alluvial sand may therefore occur intercalated with fluvial glacial phases but rather from large sediments. And this will be the examples of glacial outwash, where the wind from where the wind blowing over the outwash plain from here, wind blowing from here will pick up sand, a lot of sand, and make up the redeposited locally from here in the side of the valley, the side of the valley. The wind blowing from here, and it will deposit from in the side of the valley, like this.
Warahmatullahi wabarakatuh dan salam sejahtera. My name is Hasif bin Tuah, code matrix code 2021117541, and in this part I will present about depositional process and setting. Ladies and gentlemen, and I will start with my first point, which is Aeolian transportation system. So in the Aeolian system, there are a system of transportation. In the desert, sortation is considered the most common sediment movement. This is because the particles, such as sand grains, when the wind speed reach high threshold, the sand grains will be lifted from the surface. The particle move in a parabolic pattern and continuously. Producing a sandstorm is a process happen in large scale. But when the particles sand grain is too large for the wind to lift, it will still move, but it rolls with the movement of the wind, but still stick to the surface. Next, we will have suspension. Should the sand particle is small, such as 70 micrometer or less, the drag force from the wind will lift the particle into suspension, and this the motion will usually will maintain because the particle is not does not really affected by its attraction to the gravity. Now we will be going to aeolian bed forms and sedimentary deposits. The first one, when the process will form the bed forms. The formation of bed form is not exclusive to desert, but the pattern can be found at fluvial, glaciofluvial, and deltaic and deep seas. And it is from its streambed sediment to the interaction between flowing wind and sediment, while in the sea, the flowing water. Bed forms can range in sizes from few centimeter to many meters. All right, let's get to the ripple and dune formation. A ripple usually have a length less than 50 centimeter and height of 40 centimeter, 4 centimeter. And a ripple will form when the velocity of wind reach the minimum as sediment transferred as bed load. But should the velocity of wind is higher, a dune will be developed because the erosion rate is higher at that point. The wind pushes the grain from the source side to the lee side, causing dune migration. And the ribbon flatten out as a large irregularity started to develop. So about the dune morphology, there is the Barton, uh, which is at the have the pattern of the movement of the wind, which is from upper to lower, and the star, which is occur when when the wind direction coming from three direction, and the transverse is when the wind are flowing in one direction and circulate within the bed form. And the parabolic is when the airflow went from lower to higher, and the longitudinal uh, it's it is formed when the wind move in a parallel direction, which is does not causing some intersection. So the pattern is much more consistent. So a dress compared to dune is a very large one. It has some smaller dunes and ripples on them. It can occur for have a size of a few more than 100 meters with a pattern. And sand sheet, and moving on to the sand sheet and dust. Sand sheet are flat, gently undulating plot of sand, surface by grain that may be too large for saltation. They form approximately 40% of Aeolian depositional surface. Sand sheet are formed when grain is too large or wind velocities are too low for dune to form. Aeolian dust is a silt-sized particle. It is also known as lowest deposit. Most of this dust is carried by dust storm as it is very fine grain, fine grain and structureless. This dust storm can carry on for many days and can be transported for a long distance, such as from Gobi Desert to Hawaii, and sometimes from Sahara Desert into the Europe.
Hi, my name is Darlene Scarlet, and I will be presenting about phases in the Aeolian environment. So what is phases? So in geologic term, phases is defined as the body of rock with specified characteristics or a way to distinguish rocks in terms of their physical, biological, and chemical means. So in these phases, they usually form sets that reach more than 10 meters of height, and they are commonly interacting with the fluvial sediments. So fluvial sediments, they come from the fluvial environment where the sediments are being deposited by rivers or streams. Okay, so these are the general morphology of Aeolian dune phases. So in these phases, it has 4 main phases. Consisting of AE1, AE2, AE3, and AE4. The first one is AE1. AE1, it has pale yellow in color, medium grain size, well-rounded and subangular quartz grains, constitute sets of cross-bedded sandstones up to 2.7 meter in thickness, and it is due to the migration of Aeolian dunes by avalanching in the lee slope. As for the AE2, it has orange to light brown in color, fine-grained sandstones, well-rounded quartz grains constituted by laterally fine lamination that are less than 3 mm in thickness. It is due to the grainfall strata that related to the saltation of grain in particles over the brink of a dune. Okay, next is AE3. AE3 also has pale yellow in color, just like AE1. It has fine to medium grain in size, subangular to well-rounded quartz grains, but constituted by sets with planar or true cross-stratification that may reach 1 meter with inversely graded sand tongues up to 15 mm thickness. So this AE3 is due to the grain flow strata related to the avalanching in the dune lee slope during the dune migration. Next is the AE4. It has yellow-white to salmon pink color, fine grain and well-rounded quartz grains, constitute with irregular or sub-horizontal laminations up to 2 mm thickness, and it is due to the wind ripple lamination or translatant strata to migration of wind ripples. Okay, so from the first picture, this indicates the AE1 phases. From here, we can see the dune cross stratification on a deformed surface and set of grain flow tongues. Grain flow tongues is the avalanche grain flow that comes from the upper towards the toe of the dune. So it will narrow its size as it goes, narrows and lengthens its size as it goes down the dune. Okay, moving on to the next picture. On the left, upper left of the slides, we can see this picture indicates the AE2 facies. From here, we can see the granite deposits in the upper, from in here, in the upper part of the Aeolian dune. Next is picture on the right, upper right of the slides. From here, we can see the granite floor tongues merging with wet interdune deposits. This is the interdune. Okay, the last picture, the lower right of the slides, indicates the AE4 facies. From here, we can see the wind ripple, translatant strata. So in these facies, they used to be less than 1 meter thick, and they may show translatant strata. Translatant here means translation, like the deposits appeared of having created by the translating of the ripple surface. For instance, like the wind ripples leaving deposits. And next, the lateral extension, they reaches few tens of meters. Lateral extension here means this has something to do with, if I'm not mistaken, has to do with the principle of lateral continuity, where layers of sediments, initially they extend laterally in all directions, like they keep on moving in all directions. So in other words, they are laterally continuous. So over time, as a result of this process, there are, as you can see now, there are rocks that they are the same, but they are separated by the valley or due to the erosion features. So that is the cause of lateral extension, like it's moving in all direction. So these are the general morphology of these facies. Okay, so in these facies, it has two main facies consisting of AE4 and AE5. So in AE4, it is the same as in Aeolian dune facies, but what I want to emphasize here is on AE5. So AE5, it has salmon pink in color, fine grain, well-sorted and well-rounded quartz grains, well-sorted horizontally laminated sandstone, which make up 10 to 20 mm in thickness. Biotubation is very scarce, and it occurs due to the flat-bedded sandstone that relates to the stages with high wind velocity and restricted sediment availability. So biotubation here means that it rarely occurs, but it can happen. So biotubation is a biogenic process of sediment particles and pore water that changes the chemical and physical properties of the sedimentary. So biotubation, for example of biotubation is porous rock. It is filled with the evidence of organisms that contain many elements from different sedimentary layers. Another example is massive rocks. Massive rocks contain sediments from just a single layer. So what are the significance of biotubation process? So in oil and gas industry, it can suggest a particular area that is likely to be rich in petroleum or other natural resources. It can also provide clues to ancient life in the form of fossilized animals and plant remains. So in the first picture, it shows the tabular packages of sandstones with horizontal to low angle Aeolian laminations that is less than 5 degrees. Okay. The second picture also shows the horizontal laminated flat-bedded sandstones. So this was actually an intercalated between two facies, which is Aeolian and fluvial. So this is the AE5, the Aeolian facies. You can see that the sets are salmon pink in color, and you can see that it is more well sorted rather than this part over here, which is the GMS facies. Okay, for the last picture, it shows the limit of the low angle cross-bedded sets. So the white line over here was actually the set boundary. Okay, so in these facies, they show irregular lenses of fine-grained massive sandstones of pale brown color with occasional mottling. So mottling is like on the surface of the sediments, the color pattern consisting of patches of different colors or different shades of color. That's what it means by mottling. And these are also the general morphology of these facies. Okay, so in these facies, it also has two main facies consisting of AE4 and AE6. So AE4 is the same as I mentioned before. What I want to emphasize here is on AE6. So AE6, it has orange to light brown in color, fine-grained sandstone without internal structure, mottling and scarce phytobation, rootlets, appear, and it occurs due to the remnant of Aeolian sediments related to alluvial overflowing areas. So these are the examples. The first example shows very fine to fine-grained sandstones alternating with millimetric irregular mudstone laminae. Okay. The second picture, it shows the dune cross stratification in an erosive surface, which is the hedge, and wet interdune strata with biotubulation, which is the eye. Okay, so for the third picture, it shows the external geometry of interdunes deposits. So you can see here, as you can see here, this was the interdune indicates. Okay, as for the last picture, shows the dry interdune with millimetric inversely graded horizontal lamination. Okay.
Assalamualaikum and hello, I'm Nurafiqah Aqilah and I will be presenting Facies Association for Aeolian Depositional Environment. So what is Facies Association? Facies Association is a group of sedimentary facies that are used to define a particular sedimentary environment. Well, for example, all the facies found in a fluvial environment may be grouped together to define a fluvial facies association. The first architectural elements for Aeolian is dune. Dunes, they may have interact with sediments of fluvial origin and constitute sets up to 10 meter thick. Okay, this table shows the associated facies in dune. There are 7 associated facies. The first one is AD, small avalanching deposits. The second one is ventifax, VS, as shown in the picture here. This is ventifax. Ventifax is any piece of rock that has been shaped, pitted, grooved or striated by sand or ice crystals blown by the wind. The third one is DS, small-scale liquefaction structures. The fourth one is RS, reactivation surfaces. The fifth one is deflection surfaces with angular class, DF. The sixth one is WL, wavy laminae, as shown in this one picture. It is wavy. And the last one is pinstripe lamination. Here, this is pinstripe lamination. An example of the dune is Great Sand Dunes. In southern Colorado, it is the tallest in North America, with a few dunes towering over 700 feet. In the spring and summer months, snow melt from these two mountain ranges that frame the park form the wide and shallow Medano Creek, which kind of make the Great Sand Dunes feel like a backwoods beach. Okay, the second architectural element for Aeolian is sand sheet. Sand sheet may show translated strata and constitute sets up to 1 meter thick and a few tens of meters of lateral extension. These are the associated facies in sand sheet. The first one is SS, small erosive grooves. The second one is DF, deflection surfaces with angular clast. And the third one is WL, wavy laminae. The example of sand sheet is the Selima sand sheet, or known as Selima Oasis. It is in southwestern Egypt and the northwestern Sudan. These sand sheets are the most probably almost as extensive as some of the great sand seas. The third architectural element for Aeolian is interdune. Interdune, they show irregular lenses of fine grain, massive sandstones of pale brown color and occasional mottling. These are the associated facies in interdune. The first one is SBP. It is fine red-orange sandstones with vertical bioturbation and isolated plant remains. The second one is FB. It is red dark mudstones or fine-grained pink sandstones with punctually mud cracks and paleosoils development. And the third one is centimeter FL, centimeter beds of fine red, sometimes green, sandstones with current ripples into dark red mudstones. And the fourth one is DC. It is desiccation crack. This is an example of desiccation crack, also known as mud cracks or crack muds. They are sedimentary structures formed as muddy sediment dries and contract. Crack formation also occurs in clay-bearing soils as a result of a reduction in water content. And the last one is WL, wavy laminae. An example for the interdune is the Death Valley National Park, America. It is the largest national park south of Alaska. Death Valley is known for extremes. It is North America's driest and hottest spot. The picture on the left shows a strike column of alluvial fan transition into an Aeolian dune. So this one is the alluvial fan. This one and this one. And as it goes downward, it transitions into Aeolian dune. This one. So Aeolian dune deposits tend to interfinger with other common desert depositional environment, such as Playa Lake deposits, alluvial fan deposits, and stream deposits. And in the next slide, I will explain about Playa Lake and alluvial fan deposits. Alluvial fan is where the sediments carried by mountain stream deposits at the bottom when the water slows down due to shallow slopes. It is a fan-shaped or triangular pattern of sand, gravel or other sediments that is spread by water over an area of the ground, hillside or mountain. And as you can see here, this is the alluvial fan. And this is the shallow slope. Okay. Playa Lake. Playa Lake is either a basin or depression that formerly contained a standing surface water body, which disappeared when evaporation processes exceeded recharge. So this Playa Lake only present a certain time throughout the water. Other than that, you cannot see the Playa Lake. Stratigraphy of Aeolian versus fluvial Aeolian. How do we tell the difference between Aeolian deposits and fluvial Aeolian deposits in the rock record? So Aeolian deposits, mostly sand with occasional gravel but little to no mud. They often exhibit reverse grading. In reverse grading, the bed coarsens upwards. This one, the bed coarsens upwards. This type of grading is relatively uncommon but is characteristic of sediments deposited by grain flow and debris flow. As for fluvial Aeolian deposits, the strata contain mud layers interbedded with sand and mud drapes on the crossbeds. They contain climbing ripples. Climbing ripples looks like this one. It looks like a stair, but it's not a stair, it's called climbing ripples. How about stratigraphy of Aeolian and beach environment? How do we tell the difference between Aeolian and beach sands in the rock record, since both of them are associated with sands? So Aeolian sands interfinger with playa, alluvial, and stream facies, which I have mentioned in earlier slides. Most of the time they don't contain any fossils, but if they have any fossils, they are mostly terrestrial fossils. As for beach sands, they interfinger with marginal marine facies and contain abundant of marine fossils because they are close to the sea.
So, in conclusion, we could say that Aeolian deposit can be classified using a variety of parameters because of the air and the air condition, which are the most closely associated. Uh, Aeolian deposits are well sorted and rounded, with grain size that rarely, if ever, surpass coarse sand. They can exhibit reverse grading in thin lamina on a fine scale, but rarely cross lamination. Cross stratification is normal on large scale, and finally, because of their affinity for arid habitats such as deserts and earths, they can be found alongside evaporite deposits from ephemeral streams, and as well as the poorly sorted alluvial fan and river deposits associated with flash flooding. And that will be conclude for our video presentation on Aeolian environment. Thank you.